Hey guys, hope you're doing fine. My name is Nishant and we are at the final day of week 4 of June LeetCoding challenge. Let's look at our question. Reconstruct itinerary. Given a list of airline tickets represented by a pair of departure and arrival airports, reconstruct the itinerary in order. Okay, all of the tickets belong to a man who departs from JFK, thus the itinerary must begin with JFK. Okay, so the airport JFK is the starting point. Okay, there are multiple things to note. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order when read as a single string. Okay, all airports are represented by 3 capital letters. Okay, you may assume all tickets from at least one valid itinerary, and one must use all the tickets once and only once. Okay, so let's look how we can solve this. So here is the tickets. So what we do is we just form the graph as each ticket represents a source airport and a destination airport. Okay, so let's build the graph. So the first airport is JFK. So JFK, so we will just use the adjacency list to store the source and destination nodes. So, and for the destination airports we will use multi-set. Okay, since a multi-set will always insert the destination airports in a lexical order, as we need to print our order in, or the itinerary in, a lexical order. So the first destination is SFO, so we will just insert SFO here. Okay, so again the next ticket is from JFK to ATL, so JFK already exists as a source. We need to put the destination in this multi-set. Okay, so ATL should be before SFO according to the lexical order. So when we insert ATL into this multi-set, we get this order: ATL then SFO. Okay, so this is it. And for the third ticket, it starts from SFO and it goes to ATL. Okay, so this is it. And for the fourth ticket, it starts from ATL and goes to JFK. Okay, and the fifth ticket and the last ticket is from ATL to SFO. So SFO is should be lexically after JFK, so it should be here. So okay, we are done with forming of the graph. Now what we do is we do the depth first search, and we do it until each airport's list is fully traversed. Okay, and the real deal is in the point 4. Okay, so one must use all the tickets once and only once. Okay, so we have to use all these tickets and only once. Okay, so what we do is when we use a ticket, we just remove the destination airport from its adjacency list. Okay, so let's start from JFK. So we need to start from JFK and we will go in recursion to its adjacency list, that is ATL. Okay, so now we traverse all the destination airports that has its source airport as ATL. Okay, so once we traversed ATL from JFK, we need to remove this as this ticket is used. Okay, so we remove ATL from here. Okay, now we go to ATL. Now ATL's first airport should be JFK, so we again go to JFK. So we are going in recursion again for JFK. Now this JFK is been traversed, so we remove this. Now we go to JFK, so JFK is still not empty, so we traverse SFO. So SFO. Okay, so this SFO is visited. Now this ticket is used. Now we go to SFO. So SFO's list has one destination airport, that is ATL. We go to ATL and we will remove this. This ticket is used, so we will remove. Now we go to ATL. Now ATL is not empty, so we will traverse SFO again. So we'll go to SFO. Okay, so this ticket is used again. Now we go to SFO. Now SFO's adjacency list is empty, so we are done with all the airports. Okay, so we are in deep down recursion, so we just keep appending all these airports in our answer. Okay, so this is the lexical order of the itinerary. We first go to JFK, then to ATL, then ATL to again JFK, then JFK to SFO, then SFO to ATL, and ATL to SFO. So this is the itinerary in which all the tickets are used and only once. Okay, so we just return one by one these, or insert these into our answer vector and just return it. Since the first element to be inserted in the vector will be SFO, since the recursion completed here, and this will be the first item to be inserted in the our answer vector. So first, then this will append, and this will append, then this will append, then this will append, then this will go. So we just have to reverse our answer vector to get our original itinerary. Okay, let's code this. So let's use vector of strings, name it answer. This will hold our answer, and a map string to multi-set of strings. Let's name it graph. So this map will hold our graph. And okay, so let's create our graph. That is for int I less than tickets of size I plus. Okay, let's create a string from tickets 0, since the first element of each ticket is the source airport, that is from, and the second element is the destination, that is to, where this ticket is supposed to go. So we will just do from dot insert to. Okay, since we are using a multi-set for all the destination airports, we need to insert it into this multi-set. Okay, so here we completed our graph. Now what we do is we just create a function dfs that takes, let's just say, source, and remember we have to traverse all the adjacency list until it's empty. Okay, so what we do is we check if graph of source dot size, that is its destination list, is empty or not. So if it's 0, we will just stop going into the recursion. Okay, so let's pull out the first destination from this adjacency list of the source airport. Graph source dot begin So this is the address of the first destination, and this we will dereferencing it to get the value. And now we also need to remove this value from the graph. So graph of source dot erase, and we just pass the address of first destination, and we go into DFS of this current source airport. Okay, and for our answer we just push back these values to our answer variable, answer vector. Okay, so and since the itinerary should start from JFK, we will start this DFS search from JFK. Okay, and also we need to reverse the answer vector, dot end, and just return our answer. Okay, okay, this looks good. Let's just copy, paste it here, and this run code. Okay, okay, we misspelled source here. Okay, let's run this again. Okay, okay, we need to push back, put this source airport to our answer. Okay, so let's run it one more time, and it looks good. Now let's submit this. Okay, this is accepted. Link for the code is in description. Thanks for watching. See you next time.